Hi guys, can you believe that this is our last chapter that we're going to do in pre-calc? So you're going to have 3 new topics this week, 1 new topic next week, and then you'll take your last test and that'll be it. So we're going to have 2 more weeks of new material and you're done with pre-calc. Woo! Okay. All right. Today's stuff, and honestly, maybe some of the stuff for this entire chapter, of course, it's a review of some Algebra 2. I know you guys learned about arithmetic and geometric sequences in Algebra 2. We're going to, for like the sake of time and doing online learning with discussion with the calculus teachers, we decided that the geometric sequences are what we really needed to focus on. So we're going to ignore arithmetic sequences. Again, I know you learned them in Algebra 2. So the following are examples of geometric sequences. It says, what are you doing to get each new term in the sequence? So, for example, A, we have 1, 2, 4, 8, 16, 32, and so on. You can see that you're multiplying by 2. For B, it went 1/3, 1/9, 1/27, 1/81, and you're multiplying by 1/3. So remember, a geometric sequence is when you multiply. An arithmetic sequence is when you add it or subtract it. So we're going to focus on geometric, which again is all the multiplication. So a geometric sequence is a pattern of numbers in which you multiply by the same number. And we call that same number the common ratio. And that common ratio will get us the next term in our sequence. So for example, on A here, we could have picked any number in order here and divided them. So like, for example, to get our common ratio R, we could have done 8 divided by 4. Or we could have done 128 divided by 64. Or 256 divided by 128. So you always take one number and divide it by the number in front of it, and it'll give you your common ratio. So again, because sometimes they're not as easy to see as like multiplying by 2. So that'll be an easy way to get your common ratio. All right, so on to the next example. We're going to kind of discover how to find the explicit formula to find any term of a geometric sequence. So if something were to say, like, what is the 100th term? This formula is going to allow us to find that very easily. So it says, use the following geometric sequence with a first term of 2. So the very first term is 2. And the common ratio is 3, meaning to get to the next term, we're going to multiply by 3. So here it is. So it'd be 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54, and so on. So we can see that the first term is 2. The second term is 6, and we got that by doing 2 times 3. The third term in our sequence is 18, which we would get by doing that 6 times 3. Or another way we could think about it, it's like doing our first term, which was 2, times 3, times another 3. So to get our second term, we multiplied by 1 3. To get our third term, you'd multiply by another 3. So another way we could write that is 2 times 3 squared, because this 3 times 3 is like 3 squared. So if we go down to the fourth term, again, you can see the progression here. It's 54, and you got that by doing the third term, which was 18 times 3. Or we could do our 2 times 3 times 3 times another 3. So that's like saying 2 times 3 cubed. The fifth term is 162. And again, you can see the pattern here. We would have done 54 times 3, or we would just tag on another 3 here at the end. So that would have been like 2 times 3 times 3 times 3 times 3. So 4 3s. So we could write that 2 times 3 to the 4th. This allows us to discover what any term could be. Your answer, what it is, will always equal your first term. So in this case, 2 times your common ratio, which in this example was 3. And notice the exponent is always one number less than the term you're on. So like on the fifth term, our exponent here on our common ratio was a 4. So it was like doing 5 minus 1, which leads us to be able to, let's say we wanted to do what is the 18th term in this sequence. I would do my first term, which was 2, times my common ratio, which was 3. And then again, I do 1 less than the term I'm looking for. So 18 would be 18 minus 1, so 17. And when you put that in your calculator, you get that number there, 258,280,326. So again, that leads us to this explicit formula for any geometric sequence. So whatever term you're looking for will always equal your first term, a sub 1, times your common ratio, times whatever term you need, minus 1. And that n minus 1 is the exponent. All right, so let's do an example here. It says to find the 10th term of a geometric sequence whose first term is 5 and whose common ratio is 2. So here's our formula. We know our a sub 1 is 5, and we know our common ratio is 2. So our first term is 5 is going to go in here. The fact that our common ratio is 2, we're going to replace here. We're looking for the 10th term, so that's going to be what my n is. So when you put everything in, you'd have your a sub 10 equals 5 times 2. And then remember, we're doing 10 minus 1, so the 9th power. And you should get 2,560. All right, next example. So on this one, it's written out as a sequence, and it says we have -4, -12, -36, -108. So again, remember the formula says to put your first term first. Here we have to figure out what our common ratio is. And many of you probably could see, well, when I do -4 times 3, I get -12. -12 times 3 is -36. So that's how 3 is here. If you couldn't see that like right away, you could always just pick a term in our sequence and divide it by the number in front. Like I could have done -12 divided by -4 and gotten 3. Or -36 divided by -12 and gotten 3. So when you put this in your calculator, we wanted to find a sub 11. So that just means we want to find our 11th term. So when I do my n minus 1, it would be 11 minus 1, which is 10. So a sub 11 is -236,196. All right, third example like this. So our sequence is -3, 12, -48, 192. So again, we can see that our first term is -3, but we also have to find our common ratio. So you're going to do 12 divided by -3, or -48 divided by 12. And you should see that the common ratio is -4. We're trying to find the 10th term. So when we put it into our formula, we would do 10 minus 1. So that's why there's a 9 here. So now in your calculator, you would do -3 times -4 to the 9th power. And when you do that, you should get 786,432. All right, last example. All right, a word problem. It says a virus reproduces by dividing into 2 after a certain growth period. So basically it's doubling. So like if it started at 2, it would be at 4 next, and so on. Kind of like the coronavirus. Fun. All right, so a virus reproduces by dividing into 2, and after a certain growth period, it divides into 2 again. As the virus continues to reproduce, it will continue to divide into 2. How many viruses will be in a system starting with a single virus after 10 divisions? So first thing it's asking is the sequence arithmetic or geometric? And it's going to be geometric because it's being multiplied by 2. So it says to write out the first 3 terms. So it's going to start with your one single strand of this virus, and then it splits into 2. So we first would have 1, then it divides into 2, so we have 2. Then each of these will divide into 2, and we'd have 4. So our first 3 terms would be 1, 2, 4. Next it says to write an explicit formula for the sequence. So we're trying to get this generic formula for us to use. So it's always a sub n. So then it's, remember, it's the first term, which in this case, it's boring old 1. Our common ratio, what we're multiplying by would be 2. 1 times 2 is 2. 2 times 2 is 4. So our common ratio is 2. And then it's still just raised to the n minus 1 power. So it wants to know how many viruses will be in a system starting with a single virus, R1, after 10 divisions. So after it's divided 10 times, it's technically the 11th term then. So after 10 divisions means we're looking for A sub 11. So when we plug that into our formula, we're looking for A sub 11. Our first term is 1 times our common ratio is 2. And then our exponent is always 11 minus 1, which would be 10. So after 10 division, there would be 1,024 viruses. All right, that concludes your first lesson on geometric sequences. You are now able to do the geometric sequence exit slip, and you can also do the first quizzes assignment for Tuesday. Have a great day, friends.